Imagine managing a massive industrial footprint, a municipal power grid, or an international supply chain. You are dealing with thousands of moving parts, constant environmental shifts, and an endless fire hose of raw telemetry. For the operators actually running these spaces, the day-to-day reality is often what's called swivel chair management. They physically spin between a half dozen different monitors, staring at static spreadsheets, fragmented video feeds, and isolated sensor alerts that never talk to each other. When a pressure valve blows, there is a dangerous gap in time. An alarm triggers on one screen, but to find the actual leak, an engineer has to dig up outdated 2D blueprints and mentally map those against a separate log of sensor data. Traditional software dashboards rely on slow human processing to bridge the gap between disjointed digital data and a complex physical reality. Katana-IoTwin approaches this bottleneck by eliminating the dashboard. They replace the charts and drop-down menus with an AI commander named Miyamoto. Instead of logging into a clunky enterprise portal, operators can manage multi-million-dollar physical supply chains using standard messaging apps like WhatsApp, Signal, or Slack. The platform becomes a conversation. If a facility's cooling system starts running hot, Miyamoto detects the anomaly and texts the operator, even if they are on their morning commute. The AI outlines the impending failure and asks for permission to reroute the power grid. The operator simply types execute. To allow an AI to safely manage critical systems, however, requires absolute precision. How do you give a machine perfect, unblinking awareness of the real world? An AI cannot operate on rough approximations or flat, outdated satellite images. It requires a perfect mathematical mirror of reality to anchor its decisions. The foundation of this system relies on geolocated 3D digital twins. These are high-fidelity replicas of physical environments mapped down to millimeter-level precision, and the mapping goes well beyond the exterior shell. By integrating building information modeling, the system captures the internal architecture of a facility. This means if a specific pipe loses pressure behind a concrete wall, the AI knows its exact spatial coordinates. Operators can even step into this data, navigating the industrial space immersively using VR or XR headsets. This 3D map provides the spatial context, ensuring the AI knows where every physical asset exists. A perfect 3D map is useless if it remains static. To be effective, the digital space has to feel the physical world. This is achieved through a process Katana calls IoT fusion. Thousands of physical sensors are attached to real-world assets, constantly tracking metrics like temperature, pressure, and vibration. When an event occurs, like a physical pipe bursting, that sensor feeds data directly into its exact location on the digital twin. This synchronization happens with a 12-millisecond latency. At this speed, the network functions as a real-time safety mechanism, allowing for immediate automated responses. IoT fusion acts as a digital nervous system, ensuring the map reacts as the physical territory does. While internal sensors detect pressure drops, the system still needs visual confirmation of macro-level changes, moving assets, and shifting external environments. That visual confirmation comes from the third pillar, Sky Command, a fully integrated autonomous drone fleet. These advanced enterprise drones generate their own distinct mission parameters and navigate complex high-altitude flight paths completely without the need for a human pilot. They bypass manual workflows, like swapping out SD cards, by processing high-resolution aerial imagery directly into the Katana cloud while still in flight. Sky Command functions as a perpetual visual loop. By constantly updating the 3D map from the sky, it ensures the AI makes decisions based on real-time site conditions. The 3D map, the IoT sensors, and the autonomous drone fleets work together to feed a continuous avalanche of real-time data directly into the Miyamoto AI. Using a feature called autoflow, the AI identifies hidden patterns, predicts failures before they happen, and formulates mechanical solutions. This brings us back to the operator managing a power grid from their phone. They no longer spend their days searching for problems across different screens. This shifts infrastructure management. The human role transitions from active micromanager to high-level overseer. By making physical reality searchable and programmable, Katana-IoTwin allows a 5-person team to manage the same operational footprint that once required 50. It removes dashboard friction and shifts the focus from managing data to overseeing outcomes.